goes nothing. Yeah. Heck yeah. Let me try that one more time. Whoa! I needed to have a rotary phase converter because I want to use a 5 horsepower 3-phase ring side blower as a dust collection system, and you know, I found it cheap on Facebook Marketplace, like I pretty much do everything, or find it on the side of the road or at the scrap pile at my work, wherever I can. But anyways, so I don't know if this is gonna work. I don't know if that little capacitor is going to, it's like, let me see if it's right here. That right there. Hopefully that is working and won't blow up when I hit the switches, which are right over here. So I'm going to be right here. The switches are there and the cap's there. So I'll wear safety glasses. But I'm gonna power this up. This is a 3-phase 10 horsepower motor being powered with single phase 240 volt, and that little capacitor is supposed to help kick the motor on, and this is the first step in building a 3 rotary phase converter. Safety glasses. Alright, here we go. Alright. Well, I might be putting another one in parallel with the other one. But for now, I am signing off. Alright, so I think I toasted the one capacitor earlier. Now I have 3 capacitors, and hopefully we won't toast them, but I'm only going to do a couple attempts. I don't know if this is going to work because the motor is twice the recommended RPM, so I believe that means it takes like twice as much starting capacitance to kick it over. So we'll find out. If I could just find my safety glasses. Yeah, here they are. Gotta have power. Looks like everything's still off. All right. All right, well, here goes nothing. Oh, yeah. Heck yeah. Let me try that one more time. Whoa! Well, that sucks. I really need a momentary push button, and that stinks. Probably not stuff I should be breathing in. Well, that worked. The motor kicked on. That is a success. And now I'm going to shut the camera off and vacate the premises and find a fan. Good deal. Alright, it doesn't stink too much anymore in here. I think what happened was I was excited when it started spinning that I just kind of forgot what I needed to do. Hopefully the caps that I have are still good. The one that blew up I took out, and I've got that big one and a little one. Hopefully that'll be enough, but I'm going to try not to blow them up right now. Hopefully I didn't harm the motor or anything. I don't think it's a good, it could happen, but we'll see. All right, so here we go. All right, looks like we popped the fuse. I saw a spark over there, so my guess is we popped the fuse. I mean, I am working with pretty much stuff that's not rated for the amperage, but it's just kind of a test bed. Feels nice and warm. Gotta have good quality test leads. Sounds like that one lived. That one's no good. Alright, so it popped a 30 amp fuse, but it did not pop the other 30 amp fuse. So that went to that leg. Contactor doesn't feel too hot. Guess I should unplug the power to that. Well, it tells me it was pulling more than 30 amps. So, the good news is the motor still spun. That much capacitance got it to start. So now all I got to do is change this switch out to a push button and then figure out amperage for that so that I don't blow that. I could just short it with a copper bar or something, but I kind of like having protection. The circuit's protected, but if it's protected at 50 amps, which is my welding circuit, then this stuff might cook before it trips the breaker. Always practice electrical safety. Okay, so the fuses kept popping, so I decided to just get rid of the fuses. I'm going to rely on the 50 amp breaker for the welding circuit. Here we go. That got pretty noisy. Maybe it's the bearing. Alright, well that works. Nothing blew up. Good. Alright, so we had the motor start to scream, but a little bit of grease on that front bearing quieted it up, so I'll probably need to grease up the rear bearing too, and there's a good chance this thing hasn't been greased in many of a year. But it seems to be running, so, and I was able to take some voltages, but I think for now I'm gonna call it quits on this little project until I get some more grease. So apparently when I was building my rotary phase converter, it was a while back, I went from getting the motor to start with the capacitors to testing my ringside blower, the regenerative blower that powers my vacuum table. I completely skipped or didn't film the balancing of all the phases with capacitors. And so basically what I'm going to do is show the insides of the rotary phase converter and where the capacitors are and explain what's going on. So stand by. So this is the outside of it. I've got this is just a regular toggle right here. That's what I did turn it on with, and this was my push button from the original design. Since then I have modified it a little bit to be turned on with an app, so that kind of comes in handy, so I don't have any I don't have to use my hands. I can just tell it to turn on. These right here are 2 smart switches, and yes, it's just the way I do things. It's looks kind of funny, but it works and it's pretty safe. So I'm gonna open it up and make it not so safe to show you the insides, because everything inside is a little hot. So stand by. Alright, it looks like you can kind of see what's going on. These are the capacitors right here that help balance out every phase. When you build a rotary phase converter from scratch, the voltages are all over the place, so you have to balance them out to get them as close as you can to each other, and that's what you use capacitors for. I've got 2 contactors right there. One is for the starting and one is for the running. I have my starting capacitors right down there, and then I have 3 blocks. I don't know if we can zoom in on those. They're kind of right there. There's 1, 2, 3. Those are the 3 phases. And I have taken off, you can't really see it, but underneath there I have fuse blocks for the ringside blower, and then I've got a little 24 volt transformer in there to give me power, because these contactors are 24 volt contactors. And then on the inside of the door here, let me see if we can zoom in on that a little bit. Probably. Oh! Right there. This right here is a delayed timer relay. And basically what it does is, when I tell the rotary phase converter to turn on, this turns on for 1 second. And that's all the starting circuit for the motor needs to start. And then after that, it shuts off the starting circuit automatically, and the rotary phase converter just runs just fine. And I got that out of an old control panel long time ago. And all of these, like the contactors, they all come out of old water heaters that are 3-phase water heaters, and they really come in handy. But yeah, that's pretty much it. And then all we have to do is right back to here, and then I can just say, "Computer, turn on rotary phase converter," or not. "Computer, turn on rotary phase converter." So that turns on the rotary phase converter. It hums, but it's not like annoying. And then this top one here is my dust collection system. "Computer, turn on dust collection system." And then there that goes. And now the dust collector's running. "Computer, turn off dust collection system." Sometimes it doesn't hear. "Computer, Turn off dust collection system. And then also, if I need to, there's a little button on the side of these smart switches that allows me to turn it off as well. So, but if I'm doing something and I got my hands full, I can just yell out to the Alexa and have it turn on without, you know, the sound of my, or with the sound of my voice. So, really comes in handy. It's a cool way of using these cheap smart switches. I think these things are like 15 bucks a piece. But we bought a storage unit one time and there's like 6 or 7 of them all stuck together. So I use those for automation. One thing I do want to mention is the rotary phase converter design that I went off of was listed by a guy. His channel is called S Bird Ranch, and he's the one that built his test board, and I copied that for the most part, but didn't like make it as pretty as his test board. I just had some copper bars and I held them down with lathe screws. I mean, it worked. It helped me build the rotary phase converter. I didn't have any accidents, but a bit more dangerous than the test board that he made. You have to be very careful. The copper bars, those are energized. If I would have tripped and fell onto them while I was running, I easily could have shocked myself or electrocuted myself. So don't do what I did. Always, you know, exercise complete safety. I've been working with electricity for a while, but you can always make mistakes, so you have to be super careful. But yeah, S Bird Ranch, he did a detailed video of building a rotary phase converter, and I really enjoyed his guidance pretty much. So look him up. Alrighty. Well, I think the time has come to do a load test. Just, you know, if you see anything alarming when it comes to safety, just ignore it. I'm going to be hopefully firing this thing up, and this is a ring side blower. It's going to suck in air in one place and blow out a whole bunch of air on the other side. So hopefully it won't go crazy. I'm pretty sure I've got the rotary phase converter balanced. And we have everything hooked up. Everything's ready to rock and roll, so here we go. Alright, this is the moment of truth. We're going to engage this contactor, which you can't see, which is going to kick this thing on, hopefully. kind of weird. It sounded like the idler motor. Got a little more noisy. Success! Alrighty. Well, next will be to build the dust collection system and see how well it functions with a cyclone dust separator. For now, that's it. Good day. Okay. Still getting used to trying to film myself. But every time I'm going to do something that hopefully will work out, but possibly not in a really bad way, I'm trying to film it. So anyways, so I have my rotary phase converter right here, and you can't see the motor, the idler motor. This is a ringside blower that will run my CNC vacuum table, and then this is my dust collection system that I've built from pretty much cheap to free parts. I got the Oneida Super Dust Deputy plus the bin for free, and then up top is a 2 horsepower blower that I got for 40 bucks. And so what I'm going to do is I'm going to start the rotary phase converter and then start the ringside blower because it's a 5 horsepower. And once that's running, I'm going to throw the switch and start this, and hopefully nothing will blow up or catch fire. If it does, I'll shut it down real quick and, hopefully not destroy everything. So here goes. We got everything plugged in. We're going to first fire up the rotary phase converter. Alright. Now here goes the ringside blower.